Okay, well, good evening, everyone, and welcome to the final task meeting of 2022. We will be taking a 2-month break after this and restarting at the end of January of 2023. I'm Neil Price-Jones, your current president of TASSQ, and I'm looking forward to tonight's topic very quickly, but a few comments and announcements before that. We are still looking for speakers for next year. All of next year currently is open, January through June and September through to November, this particular talk. We will provide support. If you feel you have a topic, but you're not sure how you want to present it, or you feel that there's something you want to ask or even find out about, by all means propose it as something that possibly could be spoken about, and we will definitely provide support to you. We really like real life situations where things went right. We even like real life situations where things went wrong, but we can protect the innocent. You don't have to admit to who your company is. A couple of other things, apart from the ones that came up on the slide. We will be starting the meetings with a survey in January. So if you have a question that you would like the answer to and would like to put it out to the group, and the only caveat that it has to be a closed-ended question. We don't have the ability to do, open-ended comment questions. But if you have a closed-ended question, true, false, multiple choice, and you would be interested in the group's opinion, we're going to start the meetings with that starting in next year, but that didn't get done for this particular year. We are looking hopefully forward to starting meeting in person next year, although we may be flexible. We're just not quite sure how it's going to work out in common with almost everybody else, I believe. It's really hard to tell whether this is going to occur or not. However, other than that, we will also be soliciting your input on how you would like TASSQ to run and what would be of the most benefit to you. Everything is up for change. TASSQ is entering its 30th year next year. So, every 10 years or so, we have a rethink of how we're going and what we're going to do and where it's going to go from here. So I'm wide open to all ideas of what you would like to see, how you would like to see it presented, etc. Other than that, the questions we request if you could put them into the chat window, and I or someone will monitor and ask Evan. I'll leave it open to Evan if he wants to ask for questions partway through. If he wants to do that, then he can just announce that, and anybody can deal with it at that stage. So without anything more, Evan, this was the most interesting title I think I ever saw. Maybe the most provocative we've ever had. So I'm not sure what sort of reactions you're going to get, but take it away, please.
Okay, great. Thank you, Neil. Well, let me start by sharing my screen here.
And let me put myself on mute.
Whoops, I think that's the wrong screen. Stop sharing. Sorry, this is a new laptop. I'm still getting used to which screen is which here. Let's try this one. Okay, that looks better. Can you see my PowerPoint?
Yes, we can.
Yes, we can see it.
Okay. So thanks, Neil. Again, my name is Evan Masters, and good morning, good afternoon, good evening to those of you coming to my talk. I appreciate it. And I will be talking about why test automation tools are idiots. And that is, as Neil pointed out, sort of a provocative word. And what that means, what I mean when I call them idiots, and what the implications of that are. So thanks, Neil, for putting this on. And let's dive in. So one of the challenges that we as testers experience, especially when we go the automated route, is getting this human knowledge out of our hopefully well-functioning brains into that of the brain of what I call the robot. And when I say robot, that's really the automation execution engine. So whatever flavor you're using, if that's Selenium or Ranorex or Eggplant or Rapiz, whatever, that's what I mean when I say the robot. So we have this challenge in front of us of getting this knowledge of how to do effective quality assurance out of our brain and into that of a robot. So let me begin by bringing up an example where I'm showing some business analysts or subject matter experts here who have been put in charge of, or they really own this hypothetical Acme system that does, whatever. But it's a system that they have defined to serve a business need, to accomplish a business need that they have. They are the experts, the end all be alls when it comes to this Acme system. So if we think about the statement that we need to verify that this Acme system can create a new account for each region, that's all our SMEs are going to need to know. They're going to be able to take that statement, if they were, for example, the ones to be the testers to assure the quality of the system. That's all that they need to see. We don't have to give them any other context or detail. They can take this simple single sentence and run with it to do what they need to in order to get a level of confidence the Acme system is performing the way that it should. But that doesn't really happen, right? We don't put our business people in charge of assuring the quality of the system. Instead, we have QA analysts who are in charge of that, and for good reason, right? These folks are professional testers, either formally trained or through on-the-job training. They have experience in testing, in doing things like how to author a test, how to document a test, perhaps how to use a test management system, how to log defects, how to triage, how to take defects through the process into resolution and then validate that those defects have been resolved, things of that nature. So we have QA analysts in the SDLC for a very good reason. They belong there. What that looks like in our example here, if we want to include our QA analysts in the process to the point where they can take over the functional testing from the business, they're going to get a little bit more detailed in how they would describe it, right? So they'll start to talk about things maybe like the version and the location, the deployment server, things like that, how to actually get there, and then what does it mean to actually say that we can verify something is open, a new account has been opened for each region. So this is a very good setup. We want this in a lot of cases, right? Where we've got the QA analysts on staff to be in charge of quality. Now, one of the downsides, and I'm going to talk about it as a downside, is that these folks are they have a process that they go through to do the analysis work, to author the tests, to execute the tests. And these folks, are typically well compensated for their efforts being professional testers, but that leads to cost also, right? So these tests are expensive, both in terms of time that it takes and just the overall dollars cost that it takes to develop these tests and to run them. And that's felt, especially in today's fast-paced, agile, short release cycles environments. These tests are expensive. So there's a trade-off there, right? So let's move to a different example then, where we still got our business SMEs in charge of defining the system. And what's common, right, is to engage in contract testers, whether that's, offshore, onshore, within your region or outside of your region. But these are folks who are not employed by the same people who own the application, who the business is, in charge of. And when we think about that setup, which is, again, in my experience, much more common to have these contract test entities in charge of quality, or at least in charge of testing, I'll say. When we think about the level of detail that we need to develop to provide the contract testers the confidence they need to be able to execute the test, that amount of detail grows, right? In the last example where we had the on-staff QA folks, it wasn't really that big of a jump from this simple statement that the business needs to their statement about including the version and the server and that type of information. But when we get to the contract testers, we do need to be a bit more prescriptive, I'll say, right? We've got, instead of just one or two sentences, we look at something like this, like a bulleted list or an ordered list where we're giving very, very specific instruction on what to do in this case. So let's continue this example. And this is going to get a little bit silly. I recognize that, and extreme, but on purpose. And just hang with me, if you will. What if we wanted to bring a 9-year-old in, and we wanted to be able to give a level of detail that even a 9-year-old, child would be able to do our testing, the testing that we need to satisfy the statement that our BAs came up with. Well, that's going to be a heck of a lot more detail, right? We're going to have just oogles and oogles of information in here. Put down your toys, pick up the mouse thing, turn the computer on. What is Firefox? We'll have to tell them what Firefox is and give them exact, go to this, put these letters in the box thingy at the top of the screen, and then wait for the weighty thingy to stop spinning. And if you get a pop-up, don't do anything or click no. And then at the end of this 100, row list of instructions, if anything goes wrong, then call for help. And I have an 8-year-old who, I would be shocked if she were able to sit down at a computer and go through 100 steps, start to finish, without getting distracted or bored or, just leaving because there's more interesting things in her world. But if I were to try to set her up to do that, this is the level of information that I would have to give her in order to get that far with her. So the point here is really two. There are 2 points here. The level of detail has increased substantially in what we need to do for translation from this statement to what we can give a 9-year-old. But so that's point one. Point two is it's still a human brain. We're just going from one human brain to another human brain, albeit an adolescent child, but it's still a human, right? So now let's get rid of the human. Let's bring in the engineers and the robot, finally. Bring in the idiot, if you will. And we'll start now to think about how much information and the level of detail we need to give the robot in order to accomplish the same thing. And if we do that, it's really no exaggeration here to think about the many, many, many lines of code, many, many instructions, if you will, that we'll have to give the robot in order to accomplish the same thing. And this is what I call an extreme detail gap now. We've gone from just a little bit with the QA staff on staff to a bit more with the contract staff to a lot with the 9-year-old to an extreme amount with the idiot robot now in the picture. And how do we fill that gap? And I should say at this point, I've got engineers who work for me that I've actually asked this question to, how do we go from the place where the business says, hey, I would like to automate this test. Can you do it for me? And, they say, yeah, sure. But how do you do that? How do you go from taking this simple statement to getting the gap filled in all the way? A big response that I get is, well, it's just experience, right? I know how to write code. I know that I'm going to have to do things that the business is not thinking about, like error handling and logging and exception paths. And what do I do if a step fails? Do I continue on fail? Do I end on fail? What language is it? What is that language capable of? How can I even see the application that I'm trying to automate against? A lot of it comes down to their experience. Also, and this is something I'll continue to talk about throughout the talk, is they capture what I call the does-do behavior. Oftentimes, the engineers will interact with the application that they're automating against and what that application is doing in real time, so that, a lot of times they'll do like a capture playback, which I'll get into that a little bit in a couple of slides. But you can use that for things like object identification, maybe capturing XPaths or, contents of dynamically filtered lists, things like that. They're really looking at what the application in front of them does do. They make stuff up and they freely admit this, and that's okay. They need to, right? let's say that, again, the business goes to an engineer and says, hey, I want to automate this test. Can you automate it for me? And the engineer goes, sure, let's sit down and walk me through it. And they will walk through an end-to-end example of going through, in this case, creating a new account for a given region. And okay, engineers on board with that, they understand it. And then they go to actually automate the test. And for whatever reason, because applications are generally complex, something different happens when the automation engineer tries to do it by themselves, when they try to automate it. Say they get to the middle of it and a pop-up shows up that wasn't there in the walkthrough of the test that they got. Well, they just say, okay, that doesn't seem to do anything. They're just going to close the pop-up and keep going. But they're going to make stuff up, whatever the case may be, out of necessity. I don't mean that derogatorily. It's a necessity. They're going to borrow code. If they had written a similar test the week before, or a different application that behaved the same way, or maybe they found a way to do it on Stack Overflow or somewhere else on the internet. They found a way to do the thing that they're trying to get the automation code to do. They're just going to borrow it. Don't reinvent the wheel if they don't have to. They're going to just run the test, right, and see what happens after they get it coded according to their understanding, their best view of the information that they have, how that test should work. They're going to run it. Maybe it'll run to completion and you'll get green lights across the board. Maybe it'll error out halfway through unexpectedly. Whatever the case may be, they're probably going to end up, debugging that test. Maybe it was the data wasn't there, or the environments are just slightly different, so it ran in one and not the other, something like that. They're going to find out if the test runs, and if not, they're going to have to debug it and see why not. And then let's say that they just are handed the test and they just don't understand what it's supposed to do, or what part of the test is supposed to do. They might have to go talk to the SME and say, hey, Mr. or Mrs. person that's well-versed in this stuff, this part doesn't make sense to me. Maybe they'll have to do some interviewing or emailing or whatever the case may be, or maybe they'll go, look at some requirements, whatever the case may be. They might have to go back to the source of truth on what is needed in order to fill the gap. But all these things, and probably more, right? This isn't meant to be an exhaustive list, but these are all things that engineers do to feed the robot, the idiot, what the idiot needs in order to complete the test. And really what's happening here is this process I call reauthoring. You go from this business level statement to this, the many lines of code needed to give the robot in order to execute the test. That's a reauthoring process. And we'll revisit that in a second here. So next I want to show just notionally, I think this will probably be, I've kind of beaten this horse dead a little bit here, but we think about the amount of test case detail required, going from the BAs to the, I would group the QA analysts in with the SME level here. Going from that is, there is some detail addition needed, but it's an even greater jump to go to the contract test group, even greater jump to go to the 9-year-old, but even a 9-year-old is a genius compared to automation tools. And it is a astronomical difference in the amount of test case detail required, going from, business analyst or SME, even the contract tester, to the robot. So this leads obviously to some problems. Problems like testing what the application does do versus what the application should do. I sort of alluded to this earlier, what the application does do. But we haven't really talked about what the application should do. So we'll dive into that in I think, the next slide. The reauthoring disconnect I mentioned earlier about going from that simple statement that the business is able to take and run with to the many lines of code that we need to feed our automation engine in order to get it to do the same thing. And then finally, if anybody has been a part of an automation project for any amount of time, they know firsthand, probably very painfully, how big of a burden maintenance of an automation library can be. So we'll dive into that as well. So looking at should do versus does do, I'll call them tactics of testing, right? So in the does do camp, and I should say too, all of us here, what we're trying to do is the best possible testing with what we've got, right? We're always going to be constrained by time or money or resources or some constraint, but we always want to try to do the best possible testing that we can. So if we look at the does do tactic of testing, these are some of the things that fall into that category. So capture playback I touched on before, that's very much looking at the application in front of you and capturing what it does do right now. Data-driven testing similarly is, we've got an application in front of us. Let's dump a bunch of data, into it and observe what it does do. And then we can build our tests or vice versa. But that's what we're going to look at, what it does with the data. AI generated testing. And I will freely admit here, I am not an AI testing expert at all. It's an up and coming thing in our industry. From my experience, though, what I've seen AI capable of doing is kind of studying a human and what the human does when it interacts with the application. But again, it is what the application does do. So the AI is going to look at, the human does this sometimes and it does this other path other times and this third path sometimes, and it's going to extrapolate from there what tests are needed in order to fully test this application. But again, it's looking at the application in its current state. So that's the trend I've seen, at least, and it would be great if there were AI testing engines out there that would look at the requirements also and kind of be able to meld those in with its study of the human and the human's interaction with the application. But even then, there's a discussion of, are those the right requirements? Are the requirements any good? Is the AI going to be able to tell us whether or not we have the right requirements? And I just don't see that yet. Test engineer authoring, I kind of mentioned this a little bit earlier, where the engineer is going to study the application in front of them that they're automating against and use that to develop the tests looking at the application. And then finally, somebody mentioned to me not too long ago that code coverage is a type of does do testing, in the sense that you're putting a coverage metric to the code that's literally right there. So that falls into the does do camp. Now, thinking about these things, are they important? Absolutely. By doing these things, we do better testing. No argument here. These things are important to improve our testing. So we definitely move our tick mark there. Transitioning now to think about some of the things that fall into the should do camp, requirements-based testing floats to the top of the list. I'm not going to touch on that in the context of this talk. That's a series of talks in and of itself, I would say. But that's, tying the testing that we do directly to the requirements. And we can do some analysis there. Again, thinking about, are they the right requirements? Modeling, though, is something that we will touch on in a little bit, and using modeling to think about what the application should do and using it as sort of a communication conduit. I actually have a different talk. I'll just give myself a little plug real quick. I gave a different talk on using modeling to get stakeholder buy-in, sort of, to really create a common understanding and move requirements analysis forward using modeling. And then finally, SME authoring, if we could get the subject matter experts to describe to some meaningful degree of detail what the test should look like. They're really the ones who are squarely in the should do camp, right? So that the test that we would ask them to author in detail would come from that place of should do. So that's the should do versus does do. And when we take both of those into account, we move our ball far up into the upper right corner, which is where we want it to be. So looking at our next problem of the reauthoring disconnect that I mentioned, again, that's going from this very simple statement into the many, many lines of code that our engineers need to feed the robot. Some of the problems that come into play, first off, is, if we think about that, the result here of the engineer's work, that code, I've yet to see an organization where we can hand that code back to the business and say, hey, look at this and make sure that it's doing the right thing. That just doesn't really happen, right? The business doesn't understand the code, and at least not to the degree where they can look at it and with a strong level of confidence say, yes, that's doing what we want it to do. And then vice versa, the engineers are in the does do camp. They're not really, I will say, privy, but it's really not their job in a lot of times to exist in the should do world, right? They're not in that mindset of thinking about the business need from its origin. I'll use the word teleological reason that application exists. So it's sort of a two-way street in that it doesn't flow. Maybe I guess that would be two one-way streets, right? It flows from the business getting more detailed till eventually we get to the code. And the engineer knows the code enough to get the test to run, but it's not a back and forth, right? They skill sets exist for a reason, right? We want the business to be the subject matter expert, and we want the coders to be coding experts. And if they are, double their salary. Well, I don't know about that, but, find those people and hang on to them for sure. Another problem here is that should do coverage is very, very difficult to measure. And, it's not like with the, we could run 100 tests and 100 tests pass. We could say we have on our % test coverage, but that's looking at what the application does do. We're not, in that case, measuring what the application should do in its underlying, purpose. And then finally, accountability here gets to be ambiguous. And this is, again, going back to the should do idea. And I want to talk about just a real life example here. Neil mentioned, we like real life situations. I don't know if this is a go right or go wrong because it's still happening. Like, this isn't a thing that I'm going to talk about that's happened. It's a thing that's happening right now. So one of the teams that I oversee is working on a project implementing an application throughout the state. And I won't name the state, so you've got a 1 in 50 chance of guessing which state it is. But one of the states in the United States is rolling out this time and attendance program. And it's sort of by iteration, in that each iteration is a new facility. So you can think of, there's a dozen of these facilities across the state. Each facility is its own rollout. And there's sort of this base core set of requirements that define it, that are going to be common throughout all 12 facilities. But each one also has its own unique set of requirements to configure to. So we finished the first rollout of the first facility, and it went as smoothly of a rollout as I've ever seen in my entire career. It was just super smooth, no hiccups, to the point where we were almost worrying because it went so well. But we took it for what it was, and everybody was happy. So we moved to the next facility, and we identify, what was going to stay the same and what was going to change, and started work on the next facility. Well, months later, we start to hear from the business saying, hey, this isn't what we wanted. This isn't doing what it's supposed to do. And we kind of scratched our heads and went back and said, well, what do you mean? This, we had the rollout, everybody was happy. Well, yeah, everybody was happy, but now that we've been using it for a couple of months, it's not doing what it's supposed to do. And so we went back to the requirements and said, hey, we did some analysis here and asked if these are the right requirements, and went through them all in depth with you, and they signed off. We have your sign off on them saying, yes, these are the right requirements. So we validated the requirements, and then we verified the system behavior against those requirements, and everything was hunky-dory. And they still said, well, no, it's, yeah, we said that at the time, but now that we're using it, it's not doing what it's supposed to do. So is that our fault? I don't think so. Is it their fault? I don't know. Maybe it's a little bit of both. I don't know. But my point here is it's ambiguous. The accountability here is ambiguous. It gets very hard to talk about accountability and should do because we're humans and we're, not perfect. And regardless of the amount of analysis we do, things are still going to be wrong. And it's just a reality I've come to accept. Even if we're right, we're not going to fight that fight because we would still be wrong in the customer's eyes. And I'm just not going to do that. So that was, again, just a real life example. I wanted to spend a couple minutes talking about to drive home this point that accountability is ambiguous. So moving on to the third problem then, maintenance. And again, this is something felt by many of us, I'm assuming, where the business is going to say, oh, I've got to change, but don't worry, it's little, right? So it shouldn't take you too much work to update all the scripts. And in our example, we'll say, the Verify the Acme system can create an account for each region and now each sub-region. Okay, simple change, right? Not a problem. And that's true for the business, right? They can just say, okay, even if they're documenting the test, they can just add sub-region to their Word document or whatever it is, and maybe run a couple extra tests and they'll be happy with it. When we start to think about how we're going to feed that to the robot, though, and what that change is going to be like, then we start running into problems where we're going to have to do some work to identify what the impact of that change is, which many of us, I'm sure, can say from personal experience is a very intensive, laborious, tedious process to do impact analysis. And sometimes we'll know the answer and sometimes we won't. Sometimes the way you do the impact analysis is by running the test, seeing what happens. Other times it's going to be broken. The entire test is just garbage. Sometimes it's part of the test is broken. And we just update that test. Sometimes it's a brand new test that we'll have to run. But in any case, it's probably going to end up to the point where maybe we need to throw some more bodies at it, get some more engineers involved to do the update. And it's certainly going to take more time and probably more time than the business expects. I've even seen projects to the point where, the maintenance burden dwarfs by far the original effort to create the automation library in the first place, right? And that's not something that many business folks, understand, but it is something I've seen where that burden is equivalent or greater than the amount of time taken to actually create the tests in the first place. So not a good situation. So maintenance burden, that can be huge for automated testing. So let's transition now from problems to solutions, how we can start to make our idiot less of an idiot. I mentioned modeling. We'll get into that in a moment, in the next slide, I think. Keywords, though, this is something that some of us may have experience with. Keywords can mean different things to different people. I like to tell people that the definition of the word test varies day to day. I could walk into 10 different organizations and ask for the definition of test, and I would get 11 different answers. So keywords isn't quite as bad, but there are a couple of different flavors of keywords. So I'll define what I mean by keywords when we get to that point. And then finally, code generation, how we can use code generation to help us with automated testing, and specifically when it comes to the maintenance burden. So if we look at modeling, again, this is a solution in the should do camp. We can build models of what the system should do, the intended behavior of the system. And there are many different types of models out there. You may be familiar with some of them. I've got a couple examples up here: activity diagrams, use case diagrams, sequence diagrams, and class diagrams. Excuse me, all UML maintain standards for these diagrams here. And, I hear a lot of people say flowcharts too. In my experience, excuse me, what people mean when they say flowcharts is some kind of a behavioral diagram. typically an activity diagram where you've got some activities and some decisions. Some actors might be involved, and you're talking about what happens as you go through this flow. So these are all good types of diagrams to use to visually represent requirements. That's what I think of when I say modeling, is we're taking the language-based requirements and augmenting them with some kind of a diagram or a picture. And again, that other talk I have, I think there's a recording on our website, talks about the power of using diagramming and modeling to really bring stakeholders onto the same page, stakeholders at every level, from the business down to development and test. And then there's another type of diagramming that I want to bring up. It's maybe not something most folks are familiar with, called cause-effect diagrams. And this is not an Ishikawa diagram. It's something different. So cause-effect diagramming is a type of diagramming that uses inputs and outputs, or causes and effects, to represent a system. And just a quick note, I won't mention this much more, but there's a tool out there, it's actually my company's tool, that uses the diagram to automatically create tests. So regardless of what type of test, or excuse me, what type of diagram you're using, model-based testing is another form of looking at should-do type testing and using that to really make the best possible tests that you can, using your diagrams, either deriving the test from the diagrams or having the diagram automatically generate the test. So modeling is a good way to introduce should-do testing. So next, let's look at keywords. And, there's a lot of different terms for what people mean when they say keywords. So you may have heard action word. There's solutions out there that use the term scriptless testing. Somebody pointed out BDD, using like gherkin or cucumber. Those can be thought of, those given, when, then statements, as types of keywords. And there are others out there as well. But what I mean is, and I'm just going to read this, a human readable term that defines an action on an object with specific parameters that link a human test or a human test action to automation code. So if we look at an example of that, we can take a statement like verify the balance for the account on the My Account screen matches the latest statement balance. So this is a very human readable statement here, and we can break it up into the different parts. Verify is going to be our keyword. So that's, when we say an action on an object, that's our keyword. Verify is our keyword. Well, what's our object? It's the balance for the account on the My Account screen. So this is the My Account screen, and this is the balance. So it's not just an account on a screen. It's the balance for the account on a My Account screen. So it's very specific, the object is. And a lot of times we can define those in a lot of different ways, whether it's static or dynamic, but in a way that obviously very uniquely identifies that object. And then the parameter is the statement balance. So this can be a literal parameter, something we pass in and we give it, a literal value. Oftentimes it's something like this, where it's a lookup value. Whatever the case may be, it's that parameter, that we use to match our object value in order to validate it. So how do we get to this point where we've got a keyword? Well, we need what we call a framework, or what I'll call a framework. So this does take an engineer would build the framework of keywords, objects, and then how to get to the parameters and store them in some kind of a repository, a database, or a library of some kind. The distinction here, though, is that the automation engineer is doing the definition of the keywords and the objects and the parameters, not the tests. They're not creating the tests. They're writing the automation code that defines the action of the keyword, how to identify and locate the objects, and how to get to the parameter. So that's the difference. They're not developing tests, they're building and maintaining a framework. So they don't need to know, if we think back about that reauthoring problem, they don't need to know much about the system or how it behaves. They need to know about the pieces that make up that system. So if we expand that example out from that simple statement into now a full test, a keyword test, it could look something like this. So start demo app and then a parameter where, we can find that demo app. Verify the current window is login. So verify is our keyword, current window is our object, login is our parameter. Set account ID to blank, set the password to blank. So set is going to be our keyword. Account ID is an object, blank is a parameter, password is an object, and then same parameter of blank. But this is what it would look like. This is a keyword test. So very human readable. The business could write a test like this. QA engineers certainly could write tests like this. Contract testers could write tests like this. My 8-year-old may even be able to write a test like this, given enough time and, candy as motivation or something like that. And another thing to point out here is the keywords are reused too, which is awesome. So we're going to use the set keyword to set our account and set our password. We're going to click on a button. We're going to use click multiple times. We're going to use the verify keyword multiple times. And that is huge when we think about maintenance, right? That was one of our problems, is how do we overcome the maintenance burden that we take on from automated testing? Well, if we build a framework, these actions or keywords are defined once, and then they're referenced whenever we need them. That's what really makes it a model of, and this is a different kind of model than the diagrams I was showing before, but a model in the sense that it's normalized, right? So we're going to define what set means one time, and then we'll call that as many times as we need to build our tests. And that way, if the way set changes, we change it in one place, and then that propagates to everywhere where we're calling that set keyword. And that expands to any keyword that we're using here. So keywords are a way that we can reduce maintenance burden and reduce the amount of gap from that test detail needed from the business down to the robot and at every step in between. So let's look now about code generation and how the keyword solution is going to help us solve that. So on the left here, same keyword level script or test. I guess I would call this a test. And then on the right, we have the code that the robot needs, the idiot needs to actually run that test. Well, what happens when we use keywords is each of these keywords is linked to the snippet of code needed for the robot to take that keyword and do that action. So our first one here, start the demo app. We can point to where that code snippet is in our script. If we look at our next action, verify the current window is log on, that's this code snippet here. Setting the account ID to blank, we've got a little bit more code required to do that, some error handling in there maybe, what happens if it can't find that object. And then similarly, password setting to blank is going to look like this code snippet down here. So when we do that, we take this keyword level test that, again, any actor we've talked about in this process could author and link it to these keywords, which attach on the back end to the code snippets. This is what gives the robot exactly what it needs to run the test. So is the robot still an idiot? Yeah, probably, but we're being very intelligent and very efficient and very effective in how we give the robot the information that it needs to actually run this test. So to conclude, some things to talk about or to think about and to just sort of recap what we've talked about so far. Should do versus does do is something I encourage you to think about as much as you can, like not just what the application is doing. Yeah, I didn't get an error message, but is it doing what it should do? That might involve going back and talking to the business or reading the requirements, understanding what the application should do. One solution to that, or one tool to help you with that, is modeling. Draw a picture. Picture's worth 1,000 words. I think some pictures are worth 1,000,000 words. And using that picture to really explicitly define what the language that defines the system is saying. If we're experiencing this reauthoring disconnect, use keywords to shrink that gap to what I found to be to the maximum amount of shrinkage. So maximize it to the minimum. How's that for a tagline? Minimize the amount of detail gap going from the business statement to what the automation tool needs to be able to run that test. And then test maintenance is a huge burden. Again, anybody who's been involved in an automation project probably knows this. If you use a tool, and there are many out there, not just the tool my company has, but there are a number of tools out there that will allow you to do code generation and then enjoy benefits like single point of change. You may have seen that acronym SPOC, SPOC, single point of change, so that you don't have to spend as much time doing impact analysis and code updates. You know where that thing is in your framework, and you just change it in your framework, and then that change propagates to all the tests in your automation library. So, my company has seen a lot of these problems in real customers' projects. We very much sympathize with those of you on the front lines who are experiencing these problems. And we really are dedicated to, using our experience and our tool set and the things that we've seen effectively work in the past, and sharing that with everybody. So that's the talk that I have put together tonight, this morning, this afternoon, whatever the case may be. Thanks all for listening, and I will pause there and see if there are any questions or comments.
Okay, well, Evan, thank you very much. That was a very interesting talk, and I think it lived up to its title. You demonstrated that test tools are idiots and need a lot of TLC to keep them going. I have some comments, but I'd certainly like anybody else who's got a question to simply unmute themselves and ask at this point. If you have a question for Evan, please simply take yourself off of mute and ask directly. But while we're waiting, while I'm keeping an eye on the screen here, a couple of things did come up, Evan. I'd like your comment on the extreme detail gap. That struck home very much about, what happens when we come to doing automated testing and trying to squeeze things together and make sure that they work without taking too much time. Also, when you said we make stuff up, I just considered that to be an expediency when I was doing automated testing. It was just a way of getting the thing done before.
Absolutely.
Yeah, and the trouble was it was tempting, right? It was very, very tempting. And then I stumbled when you said double their salary. I just stopped listening at that point.
Yeah, if I had any control over the matter, I would just, poof, double everybody's.
Doubles everybody's salary. Accountability is ambiguous scares me. Very, very much so. I mean, because I'd like to think that if somebody is responsible for the test cases that have been written in the test automation and what's occurring, but yeah, you're right. It gets broken down between multiple people, which may or may not be good. So who knows, right? And by the way, you needn't be shy about coming up to Canada and talking about this. We've had a federal payroll system in Canada that I'm not sure it's right yet. Does anybody remember what it was called? Somebody want to unmute and remind me of what the name of that federal payroll system is and how long we've been trying to fix it? Okay, silent group tonight. Bob, do you remember what it was called?
I think everybody's got a mouthful of food because we're making them watch.
I hope not. I hope you guys can unmute yourselves if there's an issue. Yeah.
Is it possible it's the Phoenix pay system?
You're right. I think who just said that?
Christopher Collins.
Oh, okay. Sorry, you're off the top of the screen here, Christopher, on my list here. Yeah, I think that's the one. And how long has it been?
Since 2011.
See, there you are, Evan. Almost 12 years.
Yeah.
So don't worry, you don't need to hide the state. We've got our own problems up here. Thanks, Christopher. I couldn't think of the name. It's been so long, but every once in a while it hits the press again with federal civil servants who've still not been paid properly for the last 12 years or something.
Right.
Yeah, it was a mess, a distinct mess. Okay, anybody else? Questions, comments? I think you're right, Evan. They're all eating.
I think I have just done this enough times. I'm so good at it that I just answer every question before.
You dazzled us all into silence. Okay.
And I mean that completely facetiously.
Yeah. Oh, okay. By the way, the maintenance burden, big one, right? And I've been trapped in that. Oh, Bob, did you want to say something? I see you just took yourself off of mute there.
Now, Evan, I do have a question. If I want to connect with you offline, what's the best way to get in touch with you?
Yeah, let me drop my email in the chat here, and of course, Neil knows how to get a hold of me. But you can just reach me at emasters@critical-logic.com.
Okay, so that's in the chat now?
Yeah. Okay. Yeah, that's in the chat. And if that doesn't persist and it goes away and you can't capture it, just go to criticallogic.com and there's a contact form, and that I'm one of the people that goes to.
Yeah, it's critical-logic, Chris.
Yeah. I got that here. Thanks, guys.
Okay, no problem. Okay, well, if there are no other comments, two or three announcements. As I mentioned at the beginning, we will be off until January now. We are looking for speakers for January. I don't know what the date is yet, but it's the last Tuesday in January. We will change the format up a little bit. We're planning to put a questionnaire at the beginning and have a bit of a discussion period about it before we launch into the talk. And we are still, of course, as I said before, trying to decide whether we're going to go back to in person or not. It is so hard to decide that, in all honesty. What I'd like you to do, for those of you who are sticking around, we'd like to take a group picture at the end. So if you could turn on your cameras, and I can't even see myself on here. Oh, there I am. Hi, Darla. I don't know which way around. There we are. Jeff, Thomas, Steve, my old Jess.
Hey, Tom, I know you.
I think you're silent, Tom.
Yeah.
Okay. Anybody else before I start taking the picture? Going once, going twice. Done. Thank you very much. Have a great holiday if you're going on holiday, and we'll see you in the new year. Thanks, Evan.
Thanks, I'll appreciate it. Take care. Thanks, Neil.
Thank you.
You're welcome.